As we begin looking at our initial functions here in Algebra 2, we are going to talk about our special functions, and the ones they are really going to focus on here are, we're going to talk about piecewise defined functions, step functions. We are going to skip over the greatest integer function, and then we will continue with the absolute value function, and we'll talk about the parent function. Now, again, these should be a review, but let's just talk about the characteristics, and I will bring in some Algebra 1 references and how we learned it there to help, with some of these lessons. So, a piecewise function, a piecewise defined function, a function that is written using two or more expressions is called a piecewise defined function. What does that mean? So that means here that this function is going to be when x is less than or equal to 1, the function will be y minus x, and then when x is greater than 1, the function will be 2x. So we will possibly have we're going to have two different things going on the graph, and it may be more evident sometimes depending on the examples. But if I look at this, just knowing what I know about these two little pieces, the slope here is a 1. The slope here is 2, so we're going to have definitely two different actions going on, and it will depend based on what the domain is, because my x values are the domain. So we graph these two things. It says graph this and graph this. Let's see. Find fx for the endpoints of the domain when x is 1. Since 1 seems to be this delineation point. And then we're going to be able to plug in some values, but let's see. So we have two functions here. We have f of x is equal to x minus 3, and then we have f of x is equal to 2x. Now, the first one, this one is for when x is less than or equal to 1. So if we plug 1 in, f of 1 equals 1 minus 3 is negative 2. If we plug in 0, that would be 0 minus 3, which is negative 3. So I know when I go to graph that, I have an ordered pair of 1, negative 2, 0, negative 3. And since it is closed because it is less than or equal to, I know that I would have a solid dot, and that's what they've done here is they said, okay, when x is 1, y was negative 2. When x is 0, y is negative 3, and here's my solid closed in because that is included, and they graphed that point. That is 1. Then for the other piecewise, starting at 1, since this equation is for greater than 1, it's going to be an open circle. Greater than 1, so I will go ahead and say when it is 1, when f of 1, that's going to be 2 times 1, which is 2. I'm going to have 0, 2 with an open circle right here. And then what would be the greater than that? I can just say f of 2 is equal to 2 times 2, which is 4, so I should have 2, 4. And then that point right there, and I'm just going to connect them. And that is my piecewise function, looking at that. So as we, big things here, piecewise, this does not mean we have an inequality. This means we are talking about what values of my domain we are using. So I could continue to plug in points. Now, because, see there's a break here. It's not a continuous function, but it is continuous from these points in given direction. So just keep that in mind. That here, let's bring it over here and see if we can. Analyzing, so again, a function can be defined by all values of x, so the domain is all real numbers. The range of all real numbers less than or equal to negative 2, so we're talking about that function that we just Okay. Function is domained for all values of x because it is actually continuous along the x-axis all the way, because we do have an open circle, but it is closed here, so 1 is included. The range for all real numbers less than -2. We continue, the range is from -2 to complete, to all numbers negative, and from greater than a +2 going upward. So there is that gap that it is not included. The y-intercept is, again, being able to identify right here is my y-intercept of 0, -3. And then the function is increasing for all values of x. It is increasing because we have a general positive slope for both portions of the function. So that's what they're analyzing using those key features that we just learned in the last two sections. So here we are going to have looks like we have 3 functions, and we have, when we have something here, let's see, when x is less than or equal to 0, so this is going to include one function, less than or equal to 0. In between 1 and 3, we're going to have another function, and then when numbers are greater than 4, greater than or equal to 4, we're going to have another equation. So that is understanding that. Let's see. So let's go ahead and graph some of these. I'll make a table just to make it easier. Okay, so I went ahead and graphed each one of those functions on here, and so looking, I have f of x is 2/3 x. So when it is less than or equal to 0, so I use 0, and I came up with ordered pair 0, 0, and then I just used -2 because I knew it would make it easier for me, but -2 is less than 0, and it is -3, 2. It is including 0, so I went ahead and graphed it, 0, 0, with a solid closed-in dot, and then I graphed my other point, -3, -2, and then that is one portion of my piecewise function. The next portion is f of x equals 3. So f of x equals 3, it doesn't matter what I plug in to that function, y is going to be 3. It's going to be my output, so I would have 1, 3, and 3, 3, and I went ahead and those two are included. So I 1, 3, 3, 3, and I drew a line in between because all points in between there. And then the third function would be -2x plus 5 for all values greater than or equal to 4. So I plugged in a 4 and I plugged in a 5 and came up with 4, -3, and 5, 5, -5, and I plotted those 2 points. And those are the different functions that we have in this piecewise. So the domain of this function, let's see, depending on what is my domain? Well, it looks like I have from -infinity up to and including 0. That's part of my domain. I also have included in that 1, 2, 3, both included, so I'm using brackets. And then I also have from 4 to positive infinity. So there's my domain. Those are the domains I'm using because we do have some gaps. This is a gap, this is a gap. It does not exist in between there. And then the range. The range is going to be, from -infinity as we come up to 0, right? To 0, and it is included. And then again, because this one is incorporated into this one, so that's why we didn't have to list it separately. It overlaps. And then the other domain is 3, because it is just the number 3. So that is my range. I said domain, range. The x-intercept, it looks like the x-intercept is 0, ordered pair 0, 0. And then the y-intercept is 0, also the ordered pair of 0, 0. So let me see here for f of x. F of x for when x, for x such that x is less than 0, the function is it increasing, decreasing? It looks like it is increasing because it has a positive slope. It is neither increasing nor decreasing, and then this one is going to be decreasing. So there you go. It just depends on what kind of key features we're talking about analyzing. So that is how I could plug values in. This is what we learned back in algebra. You know, put an input in, get an output, make an ordered pair. So there you go. Let's see here. Football coach is ordering new jerseys for the new season. The manufacturer charges $88 for each jersey when 5 or fewer are ordered. Okay, so the function is when $88 per jersey if 5 or less are ordered, $75 each for orders of 6 to 11, $75 times x if I order between 6 and 11 jerseys, $65 each for an order of 12 to 29, so $65 times each jersey for 12 to 29, and then $56 each for 30 or more jerseys. So anything greater than 29, I don't know why they wouldn't just say 30 or greater, but anything greater than 29 is going to be $56 each. So thinking about that, what will the cost be to purchase 11 jerseys? Okay, this is the 11 jersey category, so it would be 75 times 11 is equal to, and we come up with a value. What would be the cost of purchasing 25 jerseys? Well, it would be 65 times 25, which is equal to. So we have to keep that in mind that when we are determining the criteria, we have a different value that we're charging. And then evaluate f of 29. F of 29, so if we purchase 29 jerseys, that is going to be 65 times 29. So as I plug in those values, if I order 11 jerseys, it's $825. If I order 25 jerseys, it's $1,625. If I order 29 jerseys, it's $1,885. Now here's where it comes into play that if you have a concept of understanding numbers and what's going on, if I order 29 jerseys, I'm not very smart. And what do I mean by that? Well, for one, because I ordered 29 jerseys, I'm paying a different price than if I ordered anything greater than 29 jerseys. So if I were to order 30 jerseys, I would get a discount off each jersey. And if I ordered 30 jerseys, it would only cost me $1,680, which is a $200 savings to purchase one more jersey. So I'm just sort of showing you that understanding numbers benefits you throughout life. But this is a common mistake people make all the time that they don't understand, so they would have actually made an incorrect purchase and spent more money than necessary. And businesses love that. Okay, so for a step function, common type of piecewise function is a step function. And it has a graph that is a series of horizontal line segments that may be resembling a staircase. So, you know, this is sort of like what we were just talking about, an example. And then a function, step function is defined as a set of constant functions, and then the domain of a step function is an interval of the real numbers, and the range of a step function is sort of discrete numbers. So as I look at this, my domain actually extends from here all the way to here. There's my domain. So my domain is anything from -4 to 4. My domain exists there, but now my range actually only exists at 3, -1, and -3. So my range is only 3 values here because of where it intersects the y-axis. So keep that. That's what they're describing there. All right, so the cost of mailing a first-class letter is determined by rates adopted by the U.S. Postal Service. These are old rates. The rates adopted in 2016 charge 47 cents for letters not over 1 ounce, 68 cents for not over 2 ounces, 89 cents if not over 3 ounces, and $1.10 if not over 3.54 ounces. And completing the table below, they said between 0 and 1 is 47, between greater than 1, right, greater than 1, and up to 2 is 68, greater than 2 up to 3 is 89, and then greater than 3 up to 3.54 is $1.10. So when we graph that, thinking that in between, this is going to be an open circle, closed circle, open circle, open circle, open circle, closed circle, closed circle, closed circle. So between 0 and 1, right, between here and here, is going to be 47 cents, which is approximately right there. Open circle. You can't tell that that's really an open circle, but it is. I'll just make it bigger. And then to my closed circle. And then at 68 cents, roughly right here, to 2 is graphing that, and then go at 89 cents, roughly here, because it's an estimate, I'm not perfect, to 3, and then from 3 to 5.4 is going to be $1.10, which is about here to here. And then that is how I would graph my step function. And there you go. And it says place a circle on the left of each segment, the main, including the segment below. So there we go. Understanding what these signs meant and how to know what is open and closed on each one. So here, state the domain and the range. The domain such that it was greater than 0, but it was less than or equal to 3.54, I believe. And then the domain was actually, or the range was only 4 values. So that would be 0.47, 0.468, 0.89, and 1.1 were the actual range values, just those 4 increments. There were no costs in between those values. And then here, if we look at this check, Chris and Joaquin design figurines for board games and toy companies. The rate they charge, here's my rate of cost, depends on the number of hours X they spend creating figurines. Draw a graph that represents the charges, state the domain and range. So as I graph that, I've gone ahead and graphed my points using my open and my closed dots from the regions of X at the value of Y that they have asked. So looking at this, I can see that my domain then goes from greater than 0, all values of X such that X is greater than 0, but is less than or equal to 50. 50. And I can see that just, if I look at my table, I went from 0 greater than 0 is less than X to X is less than or equal to 50. And then my range, of course, is going to be my Y values here. And then my range, having difficulty here, my range is going to be all values of, actually, just, I'm just going to go with my 4 numbers. 500, 1,400, 2,500, and then 4,000. Those are the actual range values. So looking at that piecewise function. Let's see, we're going to go ahead and skip this greatest integer function this time and move on to absolute value. Okay, so what absolute value function is a function that contains the algebraic expression within the absolute value symbol and it can be graphed as a piecewise function. So looking at this function, we have this absolute value function. Looking here, this is the basic absolute value function, and it has a domain where it goes on forever to negative infinity, and it goes on forever to positive infinity, all real numbers. My range, however, in this case does not exist down here in the negative region of the y-axis. It only exists for positive values of y, so that's why they say that the range is all non-negative real numbers. And then my intercepts, my y and x intercept both happen to be the origin, so at 0. Now, things to remember, and I have it right here, is the basic transformations for functions also applies to absolute value functions. So a function, you have a, which makes it enlarge or shrink, depending on how you want to think about it, and also flip upside down, up, go open up or open down. Inside the absolute value or the grouping symbol, you have your h, and then outside you have your k. Now your h and your k is going to identify the vertex of a function. And then, of course, depending on the value of h and k will depend on if it moves up, down, left, or right. And then that a, of course, stretches it. But so thinking about that, you got to remember that inside the absolute value, you have all things positive and negative, and we'll get to that in the next example. But to graph this absolute value function, they came up with some points. They used -4. This is graph f of x, which is the absolute value of 3/4 x plus 3. State the domain and range. Now, what they're saying here is they pick some points, -4, -2, 0, 2, and 4, and they plug those values into their function, and then they got the y value out. So x in, y out, x in, y out, x in, y out, x in, y out, x in, y out. And that gave them their ordered pairs that they could graph, right? Their x and y's, and then they came over here and they graphed them. How did they pick those points, those numbers? I could have picked a number that was nowhere near my function to see the vertex. Well, remember, understanding that the vertex here is 0, 3, right? H, K. I know that if I'm 0 is the x value that will give me my vertex. So if I graph around that one, I pick numbers on either the left or right of 0, I'm going to see this effect. So understanding that will give me the shape I'm looking for where I can graph it. So that's what they did. They plugged that in, and I will just say that the domain is still absolute value function is all real numbers, because it goes on forever to positive infinity and negative infinity. My domain, however, started at y is equal to 3, and it was for all values greater than also, so it would be y is greater than or equal to 3. So that's what they are coming up with the domain and range. So again, looking at this example, I have the absolute value of x minus h plus k. So my vertex in this example is going to be, I meant to put x minus 1, right? So my vertex is going to be 1, 3. So I know my vertex is going to be right there. Now, to graph it, I would just pick some points on either side of that, and I can pick, let's put in f of 0, f of, I'm just going to do 2 points, and then f of 3. So that would be the absolute value of 0 minus 1 plus 3 is going to be 1 plus 3, which is 4, so I have 0, 4. And then I have the absolute value of 3 minus 1 plus 3, which is 2, plus 3, which is 5, so I have 3, 5. And then there we go, we have my function I can graph. I didn't need to put a lot of points. So there we go. State the domain and range. The domain is still going to be the same. The domain is all real numbers. The range, y is greater than or equal to 3. That is my range. And then my domain was all real numbers. So again, a lot of this hopefully is a review for you. Now, graphing it with a negative coefficient. Let's see, what do we have to remember? We have to remember that an absolute value can be either a positive or negative number. So in this case, the inside of my absolute value can be positive or negative. So if I were to do that, thinking about what is inside, in the case of the positive value, if I distribute the -2 to the positive information, this is part of my function. That is going to be one direction. And then if I have the negative of it, I would have minus negative times the entire thing in parentheses. And when I do that, that portion, the negative value, would be 2x plus 2. So these two things we have to consider. And then they talk about here how to find out where my vertex lies. If we make those two things equal to each other and solve for x, we find out where my vertex is. And they say that my vertex is -1. Well, if you remember your vertex form, your absolute value transformations, I would have here -2 times the absolute value of x minus h. So since it's x plus 1, that would be x minus a -1. And then k out here is 0. So it would be, I know the vertex should be -1, 0 by the understanding of functions and how they are manipulated. So I know that my vertex should be -1, 0. So just keep that in mind. Now, also, since this is a -2 on the outside, I know that the function opens downward because that's what the negative did. It flipped it from opening up to opening down. But as we plug in values, we can also just say, okay, if that's my point, I'll take f of, let's see, I'm just going to pick -4 is equal to, and then f of, I'll say positive 4. So here, when x is less than -1, this is right here, x is less than -1, I'm going to use that function. So that would be 2 times -4 plus 2, which is -8 plus 2 is -6. So I have ordered pair -4, -6. So -4, -6. I should have picked something closer, huh? So I'm going to pick something different here. I'll pick 2. And then when I have a positive 2, I use this function when x is greater than or equal to -1. So I'm going to pick a positive 2, and that would be 2. So -2 times 2 minus 2 is going to be -4 minus 2, which is -6. And so my ordered pair is 2, -6. Looks something like that. There you go. Hopefully that's what your graph looks like. Now I should have picked some values differently. I should have probably gone to f of -3, and that would have given me an ordered pair of -3. -3 should be giving me -4, right? That point. And then if I would have picked a positive 1, f of 1, that would have given me a 1, -4. So that would have been on my graph. That would have been a better way to do it. And then, so that's how we graph these piecewise functions. And looking at this next example, state the domain and range. Before I even graph it, if it's an absolute value function, I know my domain is all real numbers. Okay? Before I even graph it, if I understand that transformation, I have 0.25 absolute value of 8x minus 0 minus 3. I know that my vertex should be 0, -3. Okay, that should be my vertex. I know that the graph, since this A is positive, that it opens upward. So I know that this is going to open this direction. So I actually know that my range is y is greater than or equal to 3. -3, sorry. Now I need to go back and I need to plot points to graph it properly, but I can answer those questions pretty easy just by some basic knowledge of values. So with that, we're going to do some more practice, and but again, I do know that since my vertex is there, I can graph this simply by using the values of f of 2 and f of -2. And that will allow me to graph 2 points and then continue on with that. So there are some of my special functions.